Today we're looking at lesson 4.06, taking sides. Today's objective is, given an inequality with the variable on both sides, I can correctly solve it in 1 out of 2 problems. So let's start with a review. What are the cases when we flip the sign of an inequality? We had 3 cases. Can you think of them? Let's see, we had when we multiply by a negative. Remember, we need to flip the sign when we multiply both sides of an inequality by a negative. The same was true when we divide by a negative. And then we have this other case that we talked about that sometimes we forget about. But it's also when we swap sides. Remember, if we swapped sides of an inequality, we needed to flip the sign as well. Not when we looked at an equality. Equality, you can swap sides. But when we have an inequality, you need to flip the sign. Okay, so another review. Which inequality is shown in this graph? Is it A, B, C, or D? Well, looks like the dot isn't filled in, so we can eliminate the ones with the equal signs. That's what that equal sign does, it fills in that dot. So is this x is greater than 4 or x is less than 4? So this graph shows x is less than 4, x is the values that are below 4. Another way you can think of this is if you look at this inequality as an arrow, you can see it would point to the left. That's an arrow that would point to the left. So if we have the variable on the left side of the inequality, this arrow points the same direction as the graph. When we turn the inequality symbol into an arrow, it points the same direction as the graph. So that's just a good tip for helping to remember how to graph inequalities. And one more review question. What's the first step in solving this? So we have an equation here, not an inequality, but we solve these similarly. Let's see, we circle our variable. We can highlight our other terms on the same side. So what is our first step to solving this? Well, we're looking to get rid of the terms that are furthest away from the variable. So this negative 2/3 is pretty close. This plus 4 is a little bit further away. We're going to get rid of that plus 4 first. So our first step would be inverse operation of plus 4. The inverse operation of add is subtract, so we would subtract 4 from both sides. Now this gets a little bit trickier though when we have the variable on both sides like we're looking at today. Because now, since we have the variable on both sides, we'd have to circle, and then highlight basically everything, right? So how could we determine which one's furthest away now? Which term is furthest away we need to get rid of first? It could be this minus 8. It could also be this plus 2. How do we figure it out? Well, it turns out we need to do an additional step before we get to that part of the solving. When we have the variable on 2 sides, we need to get it on the same side first. And in order to do that, what we can do is we can treat one of these terms as a unit, its own unit that we can add and subtract, and we can just subtract this from this side. We'd subtract it from this side as well, minus 2x on both sides, that's a 2. These 2x's will cancel, and then we can combine these like terms. 3x minus 2x is just 1x. We bring the minus 8 down, we bring the plus 2 down. In fact, we don't even need that plus, right? We can just say 2. 1x minus 8 is greater than 2. So once we've done that, once we've subtracted that 2x from both sides, we know how to solve something that looks like this, right? We can circle the variable, we can highlight our other terms, and now we know how to solve this. We do the inverse operation on both sides to get rid of that term. These 8's cancel and we get x is greater than 10. Now you might have a question here that would totally make sense if we scroll back to this original problem we had. And we approached this by subtracting 2x. You might have this question, why did we not subtract 3x? Could we not subtract 3x? It turns out you can. You can move the variable to whichever side you want. So if you wanted to subtract 3x, that's totally valid too. All that means is we're going to end up with the variable over on this side, and we might have to do some manipulation if we want to get the variable back on the left side. Remember, the left side is where it's easier to graph. So maybe it makes sense to move it over to the left side, but if you want to move it over to the right side, that works too. Here we would get negative 8 is greater than 2x minus 3x is negative x plus 2, and we could still solve that. We subtract 2 from both sides, we get negative 10 is greater than negative x. And now we'd have to get rid of this negative by dividing by negative 1. These negatives cancel. We need to flip the sign. Negative 10 divided by negative 1 is 10. We get x is greater than 10. Notice the greater than is over here, so we have 10 is less than x. But that's the same as we got later, which is x is greater than 10. All we did was we flipped the sign. We swapped sides and flipped the sign. So we got 10 is less than x. Remember, if we swap sides, we also need to flip the sign. So we get the same answer. It's a long explanation of basically just that you can move the variable to whichever side you want to. You get the same answer. All right, so let's work through some examples. Let's solve these inequalities. Here's the first one. We need to get the variable on the same side. Let's see, maybe I want to move it over here, so I'm going to do the opposite operation for this whole y term. We are currently subtracting, so now I'm going to add it as the inverse operation. So I'm going to add 10y to both sides. The minus 10y and the positive 10y cancel, and we get 16y is less than 8. Now we need to do the inverse operation here, so we're going to divide both sides by 16. These 16's cancel, and we get y is less than 8 over 16. That simplifies to 1/2. Or you might have put that in your calculator and gotten out 0.5. That's a valid answer as well. It is in fact the same answer. So y is less than 1/2. So remember, if we wanted to graph this, we would have a line at 1/2. We'd do an open circle there, and it would go the direction of the arrow. See, if we made this into an arrow, it would go left. So our arrow here is going to go to the left, like that. All right, let's look at the next one. I'm going to draw my line. Remember, our first step, we need to get the variable on the same side. So what do you think we need to do to get the variable on the same side? Well, we're going to take this whole 9m term and subtract it from both sides. That way we can get rid of the 9m term on this side. We have 14m minus 9m is 5m. Everything else comes down. We just subtracted so we don't flip the sign. Everything else comes down. All right, so now I'm getting m by itself. What do I get rid of first? It's going to be the thing that's furthest away. It's going to be that 12. So we're going to subtract 12 from both sides, the inverse operation. The 12's cancel. We get 5m. Again, we don't flip the sign because we're just subtracting. And then minus 15. Negative 3 minus 12 is minus 15. Our last step here, we need to get rid of this 5. And we're currently multiplying, so we need to divide it to get rid of it. Divide both sides by 5. These 5's cancel. We get m less than or equal to negative 3. Remember, we don't flip the sign because it's dividing by a positive number. So that is our answer. M is less than or equal to negative 3. So once again, if we wanted to graph this, now we have a closed dot at negative 3. Oops, this should be negative 3. We have a closed dot, and our arrow is going to go to the left. See how that's an arrow to the left? So this is the direction our graph would go. One more example on this page. This one over here, let's draw our line. Now we have a fraction. That can mess us up sometimes. We have to figure out how to deal with this fraction. But it turns out we can still just treat it exactly the same way. We don't need to let that fraction mess us up. We can just subtract that 1/2 t term. It works exactly the same way. Subtract 1/2 t. The only thing that's kind of tricky here is we need to combine these like terms. We need to figure out what 1 minus 1/2 is. Well, let's see. 1/2 plus 1/2 is 1. So 1 minus 1/2 is going to be 1/2. Another way we could do that, another way we could think about that is we could just put this in our calculator as 1 minus 0.5. And we get a positive 0.5 out, which is the same thing as 1/2. So all that is to say, 1t minus 1/2 t is going to be 1/2 t. Everything else comes down exactly as it is, and we can solve this. Let's see, we have an add 9. That's going to be the furthest away term, so I'm going to subtract 9 from both sides. Those cancel, and I get 1/2 t is less than or equal to 6. To get rid of this 1/2, we have a couple of different methods, but I'll remind you about this reciprocal thing we do. Flip the fraction upside down and multiply. Do that to both sides. So when we flip this upside down, the 2's cancel, the 1's cancel, and we just have t left. Over here on the right side, remember we can put anything over 1. We're going to multiply straight across. So this is 6 times 2 on the top, and 1 times 1 on the bottom, 12 over 1. We don't flip the sign because we're multiplying by a positive number. So our sign stays the same direction. So this is t is less than or equal to 12 over 1. 12 over 1 really is just 12, right? That simplifies to 12. So t is less than or equal to 12 is our answer on that one. That one was a little bit trickier because we had to deal with a fraction, but we were totally up to the task. We can totally deal with fractions. Okay, so we figured out what to do with the variable on both sides. Now how about if we have parentheses? What do we need to do with that? Because I can't exactly move this x over as it is. I wouldn't know what to add. It's inside these parentheses. I need to deal with the parentheses first, right? That's our first thing in PEMDAS. So what do I do to manage these parentheses? Well, what if I use the distributive property? Can we get rid of these parentheses with the distributive property? Let's see, 3 times x is 3x. 3 times -5 is -15. We didn't multiply both sides, so we don't flip the sign. Distributive property never flips the sign. And we just bring everything else down. Let's see, where are we now? Well, we have a variable on both sides. We've been talking about how to solve that, right? Let's see, let's try moving it over to this side and see if we can solve it that way. I'm going to add 2x to both sides. Sometimes I like dealing with positive numbers. Sometimes that makes things easier for me. So I'm going to cancel those 2x's, those go away, and I get 1 is less than 3x plus 2x is 5x. 1 is less than 5x minus 15. Okay, so now I get rid of the term that's furthest away. I add 15 to both sides. 1 plus 15 is 16. Let's see, those cancel. 16 is less than the 5x comes down. And then I need to divide both sides by 5. These 5's cancel, and I just get 16 over 5 less than x. Now, the only trick here is that if I want to graph it, how do I figure out which direction this goes? We have 16 over 5, that's 3.2. That's the same thing as 3.2. I know I have an open dot because there's no equal sign there. But does it go left or right? this can be kind of confusing now. Our variable isn't on the correct side for graphing. It's on the right side. So usually I would think this would go left, but now I'm confused because the variable's on the right side. What do I do? Well, we have that rule, remember, we can swap sides. All we need to do is remember to flip the sign when we swap sides. So let's see, I'll have my x, I flip the sign, and then I have my other side. So we just swap sides and we flip the sign. Now I can definitely see this arrow goes to the right. My variable's on the left of this inequality. My graph is going to go to the right. There you go. So let's do a couple of examples with parentheses with using the distributive property. Solve these two inequalities. Let's look at this first one. Let's see, I see parentheses, so that tells me I probably need to distribute. 2 times x is 2x. 2 times 6 is 12. Everything comes down as is. Remember, we don't flip the sign for distribution. Now we want to get the variable on the same side. Let's try subtracting 5x this time. So we move it over to the left. Negative 5x. These terms will cancel. I get 2x minus 5x, that'll be negative 3x plus 12, greater than, the 9 comes down. Now I subtract 12 from both sides. I get negative 3x is greater than, 9 minus 12 is negative 3. And then we divide both sides by negative 3. That's our last step. We do the inverse operation of multiplication. So these negative 3's are going to cancel, and I just get x on the side. But we divided by a negative, right? So what do we need to do when we divide by a negative? We need to flip the sign. Then we have negative 3 divided by negative 3. That is 1. So our final answer here is x is less than 1. If we wanted to graph that, we would have a 1, an open dot, and our graph would go this way to the left. You can tell because this sign points to the left. And our variable's on the left side. Okay, I want you to try this one on your own. So pause the video, try to solve this problem. It's just a tiny bit more complicated, and then come back and see if we get the same answer. All right, so we have parentheses and parentheses. We know that we need to distribute when we see parentheses. So I'm going to take the 4 through these parentheses. 4 times 2 is negative 8. Or sorry, 4 times negative 2 is negative 8. 4 times a is going to be 4a. Distribution doesn't flip our sign. And then we're going to need to distribute again through these parentheses over here. So 3 times a is 3a. 3 times 1 is 3. And now this is starting to look a little more familiar. We know that we need to get the variable on the same side. So maybe let's subtract 3a from both sides. These 3a's will cancel. 4a minus 3a is 1a, or we can just write that as a. And we'll bring that negative 8 down. We also bring the sign down and 3 down. Remember, we don't flip the sign. All we're doing is subtracting, so we don't flip the sign. And now we're getting a by itself. All we need to do is get rid of this other term, right? So let's do the inverse operation. Looks like we're subtracting here. So we're going to do the inverse operation of add. Add 8, add 8. These 8's cancel, and we get a is less than 11. Once again, if we graph this, we're going to draw an open circle at 11, and our graph, will go to the left because that's what our inequality symbol shows us, goes to the left. Okay, so now we figured out how to solve the variable on both sides, how to solve it with parentheses, we're going to look at some problems that someone else solved and find the errors in them. So here's a solved inequality. There may be more than one error. So take a look at this, try to pause the video and take a look at the solving steps. See if you can figure out where they made an error. So let's look at what they did here. Let's see, we have variable on both sides, so we know we need to move it to the same side. We're going to subtract 2x from both sides. That looks right. These 2x's cancel, so we're just left with -8. Over here we have 5x minus 2x is 3x. We bring the plus 7 down. That looks right. So all of this looks right. Didn't flip the sign. That's correct when we subtract. Now we're getting x by itself, so we're going to get rid of that 7 term. Subtract 7 from both sides. We get 3x is greater than -8 minus -7, or sorry, -8 minus 7 is -15. That looks right. Again, we subtracted so we don't flip the sign. And then they divided by 3. So we had 3 times x. Now we're going to divide by 3. Divide this side by 3. And we get x is left because these 3's cancel. Over here we get -15 divided by 3 is -5. But look what happened here. Looks like they flipped the sign even though we divided by a positive. That's not right. That's not how that works. If we divide by a positive, we need to keep the sign the same direction. So that was an error right there. That is incorrect. So if you spotted that error, great job. Let's give another one a try. Let's try to find the errors in this solved inequality. Pause the video, look for the errors, come back and see if you get the same answers. So let's look here. We again have the variable on both sides. Now they're adding 6 to both sides. They are not moving the variable. Now technically you could do this, right? You don't have to do things in the same order. The reason we do things in the order we do is mostly just to make it easy on ourselves. So it already seems like whoever's solving this is trying to make it hard. But let's look at how their next step goes. Okay, these -6 and +6 cancel. We get 5x. That seems right. Less than or equal to. Yeah, it doesn't change because we are just adding. We have 8x plus 6 is 14x. Well, that doesn't seem right. 8x plus 6, you can't combine those. Those weren't like, the 6 goes with the 3. Right, so that is definitely not right. That isn't right, and that isn't right either. 8x plus 3 plus 6 is going to be 8x plus 9. So actually everything from that point forward is pretty messed up. If we wanted to solve this the correct way, we'd have to start at this step and go from there. Let's just go through the rest of these steps just to see in case there are any other errors. Let's see, so at this point they said get the variable on both sides. Okay, so subtract 14x, subtract 14x. Those cancel. We get -9x. 5 minus 14 is -9x. Over here we have 3 that comes down. They divide both sides by -9. That makes sense because we're doing the inverse operation, divided by -9. But look at this. We divided by a negative. They made another error. They didn't flip the sign. We would have needed to flip the sign there. So they actually made 2 errors in this one. In order to fix these errors, we would need to come up here to this step and then solve it from here. We would subtract 8x on both sides. Or if you wanted, you could move the 5x over there. That would work too. These 8x's cancel. We get -3x. 5x minus 8x is -3x, and then the 9 comes down. Now we need to divide by a -3, and we need to remember, dividing by a negative means we flip the sign. So these -3's cancel, and we get x is greater than or equal to 9 divided by -3 is -3. So x is greater than or equal to -3. This is the wrong answer. That is the correct answer. All right, we have one more to find the errors. Find the errors on this one. Take a look at it. What do you see? Well, let's see. They started with distribution. This -3 distributes to the x. We get -3x. -3 times 8 is -24. They flipped the sign, though. Did we do anything? No, we just brought these down. 2x plus 1. And we did distribution. Now we did multiply by a -3 on that distribution, but remember, we don't flip the sign for distribution. We only flip the sign when we multiply both sides. Distribution is just simplifying a side. In order to flip the sign, it needs to affect both sides. So this is wrong. This should not be flipped. This should be back the other direction. So let's go through the rest of these steps. We're going to subtract 2x from both sides. We're trying to get x on the same side. That makes sense. So subtract 2x, subtract 2x. Those 2x's are going to cancel. We'll be left with 1. -3x minus 2x is -5x. That's right. Minus 24. That's right. We'll add 24 to both sides. Yep, we're getting x by itself. Let's see. This still needs to be flipped, right? It's going to need to be flipped the whole rest of the way. These 24's now cancel. We get -5x. This still needs to be flipped. It's greater than 25. Our last step, we need to divide by a negative, -5. That tells us, once again, we're going to flip the sign. Those -5's will cancel. We get 25 divided by -5 is -5. So our overall answer here is x is less than -5. So you can see the only error they really made was this very first step. They flipped the sign when they shouldn't have. But it carried through to the whole problem. We actually had to flip the sign every step thereafter to make it consistent. Another way that might have been less confusing than flipping the sign every time is we might have just solved this again. We might have just come over here and solved it ourselves rather than trying to fix their problem. And then we could compare side by side, see what we got different. If you would like to do that, you are perfectly welcome to. See if you get x is less than -5 as your answer. So that covers everything today for solving inequalities with the variable on both sides. Given an inequality with the variable on both sides, I can correctly solve it in 1 out of 2 problems.